Hello, Physics Nation. My name is Nate Larmond, and I'd like to do a Khan Academy problem from the set called Conservation of Energy, Predict Changes in Energy. So this is just a handwritten solution of what I just did. We have a little cart on a zero friction track. We squish a little spring, and then we let go. So the cart moves across this horizontal track, down this little valley, and up the other side. And it's a pretty cool website. So you check on each position and then you say, yes, it has kinetic energy, or no, it doesn't have kinetic energy. Yes, it has spring potential energy, or no, it does not. Yes, it has gravitational potential energy, or no, it does not. So you're checking boxes next to three types of energy. At position 1, it has spring potential energy because the spring is compressed from its equilibrium position, and it has gravitational potential energy, is elevated from this arbitrary minimum potential energy right here. This is 0 meters of height down here at the bottom of the valley. So it's not moving at point 1, so it has no kinetic. So you're going to check those two boxes. Why is U used for gravitational potential energy? I don't know. This college professor at Cal Poly says Rankine, a famous thermodynamics superstar, physics superstar, first used the symbol U back in the day. Hang on, 1853. So whatever. I guess this guy did his research. Ranking, it all comes from ranking. So in middle school, they usually say GPE for gravitational potential energy, and now in high school physics, we say U sub G, the potential energy due to the work it takes to separate two pieces of mass in a gravitational field. And yeah, it's above its minimum right here, so it has some gravitational potential energy. Well, after we let go, it's moving, so now it has kinetic energy and gravitational potential energy, but the spring has returned to its equilibrium position. And if there's no squish or stretch, then you have no spring potential energy. So just two types of energy here. In fact, all of the stored spring potential energy is converted into kinetic energy if there is no negative work done by friction. It's moving to the, it is moving to the left right here in the negative x direction, but friction acts to the right. So whenever work, that is whenever force and displacement are in opposite direction, negative work is done. Friction is stealing energy from this system. It's called a non-conservative force because you can't get it back. It's hard to recover energy from heat, sound, and vibration. Rankine said you actually could do work with thermal energy, but that's a whole nother topic. So let's talk about point 3. Well, it has even more kinetic energy, right? Because it's come down the little ramp right here, but we are now at our minimum height, so there is no potential energy. In fact, all of the potential energy that was lost is now transformed into kinetic energy. So only check the K box here. And finally, it's not moving at the top of the other side of the valley, so it has maximum gravitational potential energy. In fact, all of the kinetic energy, 1/2 mv squared, becomes mg delta h, or mg delta y. And here are the technical definitions of these three types of energy. Mg delta h, this is actually just work equals force times distance. Here, check it out. Hang on. Work equals, pardon my sloppiness, force dot distance. This is a scalar product or a dot product, ft cosine theta. But check it out. Mg is the weight. Okay, you just take kilos, multiply by 9.8. So the weight is the force, and delta h is just the distance. So mg delta h really is force times distance. It's the work necessary to lift something in a gravitational field. And the position of the two pieces of mass stores the gravitational potential energy. Pardon the sloppiness, this is 1/2 kx squared. Let me see if I can erase that. 1/2 kx squared is stored spring potential energy. So x is the deflection from equilibrium. You can deflect it by squishing the spring, or you can deflect it by stretching the spring. It doesn't really matter. Energy is a scalar. All right, so there's no like east joules or west joules. There's just joules. There's just energy, the ability to do work, the ability to apply a force through a distance. And finally, here's kinetic energy, 1/2 mv squared. And we don't do any fancy math. I just want to know at each one of these four positions, is there kinetic? Is there gravitational potential? Is there spring potential? Thanks for watching. See you in the next video.